In this video, we're going to look at the perimeter and area of common shapes. So perimeter, if you remember, is the distance around the outside of the object. So if we look at this rectangle, it's going to be those four sides added together. If it was this triangle, it would be h plus b plus the third side. And for the third triangle, it would be b plus these two diagonal lengths. As it's a length, units will all be in centimetres, metres, and so on. The area is the amount of shape contained within an object, and its units are centimetres squared or squared metres, and so on. Converting units of area is different to converting units of length, so it's much better to convert all the lengths to a common unit first rather than changing at the end. We should know the area of a rectangle to be base times height, and the area of a triangle to be half times the base times the perpendicular height. So these two triangles, provided that, well, if b were both the same length and h was the same height, then they would have had the same area. So it doesn't matter whereabouts this vertex is. It could be along anywhere parallel to that point, and it would have the same area. So it's the base times by the perpendicular height. Composite or compound shapes are complex looking shapes that can be broken down into smaller, simple shapes, and we find the areas separately and then add them together. So in example 16 here, we've got two composite shapes or compound shapes. And what we could do in the first one is we can split it into two rectangles. So we could put it into area 1 and 2. So we need to fill in some missing lengths. And what we know is that the height of this part of the shape is 4, and the height of the full shape is 10, which means the height of the end bit here is going to be 6. Similarly, we know the width of the full shape is 10, and the width of the left-hand bit is 5, so that means the width of the right-hand part is also going to be 5. So if we look at the area of 1, that's going to be length times base, which is 5 times 10, which is 50. Area 2, again, is a rectangle, so it's length times base. So 5 times 4, which is 20. The total area then is going to be 70 squared centimetres. For the second shape then, well, again, we've got two different distinct shapes. We've got a triangle and a rectangle. And we know the dimensions of the rectangle easy enough. So the area of 2 is length times breadth, which is 8 by 3, which is 24 square metres. The second one, well, what we can see is that it's 7 metres tall in total, and the height of the rectangle is 3 metres. That means the height of the triangle is going to be 4 metres. So area 1 then is a half times base times height, which is a half times 8 times 4, which is 16 square metres. So the total area is going to be 40 square metres. Other quadrilaterals that we should be able to work with. So we've got a trapezium, and a trapezium is any quadrilateral with one pair of parallel sides. And the formula for that is a half of the sum of the parallel sides. So A and B are the parallel sides, and we multiply by the perpendicular distance between those. And this could be in any way. So if we had a parallelogram shaped in this way, where the vertical lines are the parallel sides, this would be A and B, and the perpendicular distance would be between them. A parallelogram then is base times perpendicular height. And we can see that if we were to cut off from the height and move this trapezium over, we would form a rectangle then, where the base would be b and the width of the rectangle would be h. So a parallelogram is base times perpendicular height. A kite or a rhombus, to work it out, it comes from the fact that we've got two separate triangles contained within the shape. Now, I suppose you could think there's 4 as well. But what it is, it's the product of the 2 diagonals and then divided by 2. So for this rhombus, it's the diagonals multiplied together and then halved. And it's the same for a kite, where the diagonals are going to be the vertical and the horizontal distance as well. So that would be D1 and that would be D2. And note that the diagonals in a rhombus and a kite will intersect at right angles, and that must be true to be using this formula. So example 17, find the area and the perimeter of this kite. So the area is a half times D1 times D2. This height is going to be 3, so then on the other side of the kite it's going to be 3 centimetres down from the middle line. So the area is going to be a half of 6 times 12, which is 36 squared centimetres. For the perimeter of the kite, what we'll need to do is work out the 2 diagonal lines. Now, if we consider first of all this right angle triangle, then what we have is the base of it is 8 and the height is 3. So if we were to label the sides A, B and the hypotenuse is C, then by using Pythagoras' theorem, A squared plus B squared equals C squared, we've got 3 squared plus 8 squared equals C squared. That's 9 plus 64, so 73 equals C squared. So C is the square root of 73, which is 8.544. Now if we work with the other triangle, and just to be clear, I'll do it in this bottom quadrant. We know the height is 3. We know this blue length is 8 and the full diagonal is 12. So that means the missing length here is going to be 4. Again, we can apply Pythagoras' theorem where C is the hypotenuse. So A, B and C. Because there's a right angle, the diagonals intersect at a right angle. So applying Pythagoras' theorem here, we get A squared plus B squared equals C squared. 3 squared plus 4 squared equals C squared. That's 25 equals C squared. So C is the square root of 25, which is 5. And that gives us 27.088 or 27.1 centimetres to 3 significant figures.